fun stuff. Special right triangles to start off with. First we got ourselves a 30, 60, 90 triangle. 30 degrees. The other one's going to be 60. Okay, the side opposite of 30 we're just going to call x. The hypotenuse is going to be twice as long as that, and the adjacent side is just going to be what is the opposite side times the square root of 3. So for an example of that, say I got 30 degrees here, and I know that this side is 6. Well, based on this information, I could double the 6 to find the hypotenuse to get 12, and then I'm just going to take it and multiply it by root 3 to get the base. It could happen if it was oriented the other way as well. So maybe let's say this time 30 degrees is here. You get the point. No matter what it's oriented, just know the side opposite the 30 is the side you're going to base everything off of. Then we got a 45, 45, 90. So both of those are going to be 45, which means those two are the same. So we're going to call those x, and that makes the hypotenuse. You're just going to take that side length and multiply it by root 2. So for example, if I know those are congruent, then I know those base angles are 45, and that's going to work. So if this was 10, well, that would make this other side 10 and the hypotenuse 10 square root of 2. If you want something a little bit more challenging, which I know you do, and now let's say that the hypotenuse is going to be 11. Well, all I know is that x times square root of 2 equals 11. And so to find the other side lengths, I'm just going to divide both sides by square root of 2. Oh, roots in the denominator, hate that. So we got to rationalize it. So I get 11 square root of 2 over 2 as my other two side lengths. And so these special triangles, the reason we care about them is because that's what makes the unit circle. The unit circle is just a circle with a radius of 1. With coordinates composed from special right triangles. And here's what I mean by that. Here's going to be my unit circle. I could have, let's say, we're going to call that 45 degrees. Because the radius is 1, well, the radius is going to be the hypotenuse of every special right triangle. And so because of those relationships, I can figure out what the coordinates are. So for example, if it's a hypotenuse of 1 and a 45, I could do the same thing that we did over here. And what I would end up getting is that the coordinates would be square root 2, square root 2. And yeah, I'm actually going to show you how we get that. X square root of 2 equals 1. Divide both sides by root 2, and then you rationalize the denominator. So we get that root 2 over 2. And that represents this length, which is the x-coordinate, and it represents the height, which is y. And so that's where the coordinates are coming from. It's from the special right triangles. I could do the same thing with the 30, 60, 90 triangles, and that's where we get all of that. And so I'm not going to include a picture here of the unit circle, mostly because I forgot to do that beforehand. I'm just going to draw stuff, but you have the picture of the unit circle in your notes. And so, here, let me actually erase. So finding exact values of trig functions, if you're not given a picture of a triangle, they come from the unit circle. So for example, if I want sine of 120 degrees, there's my beautiful unit circle. Okay, so 30, let's see, 90, 120 is in here based on your picture. There's 120 degrees, and I know the coordinates at that point are negative 1/2 positive root 3 over 2. Well, remember, with the hypotenuse being 1, and this is x and this is y, and there's our reference angle, if I want, let's label these opposite, adjacent, hypotenuse, I know that sine of theta, if I could label these correctly, wow, pranked ya, adjacent and opposite. Well, sine of theta I know is opposite over hypotenuse, which is, oh, it just simplifies to y. Cosine theta equals adjacent over hypotenuse, simplifies to x, and tangent theta opposite over adjacent. So if you're asked for sine of 120, this means the y-coordinate at 120 degrees, which is root 3 over 2. Maybe I want the cosine of 225 degrees. 225 is down in here. It's negative root 2 over 2, negative root 2 over 2. Cosine wants the x of 225 degrees, which is negative root 2 over 2. Maybe I want tangent of 315. Let's actually make it 330, just because I have a feeling we'd get more questions on that one. Tangent of 330 degrees. This is root 3 over 2, negative 1/2. Oops, sorry. Well, tangent is y divided by x, so this wants, yeah, tangent means y over x of that coordinate. So negative 1/2 divided by root 3 over 2. Okay. Dividing fractions, we gotta go back to basics. I need you to have your basics down, especially before you go into next year. So if you're going to divide fractions, you gotta remember, some people say like keep, change, flip. I just say ours is not to reason why, but to flip and multiply. Basically, here's what you got to do. You're going to keep the first fraction the same. Instead of division, you're going to make it multiplication, and you're just going to multiply by the reciprocal. Those 2's cancel out. I get -1 over square root 3, but we hate roots in the denominator. So I get -√3 over 3. And that's how we use the unit circle for all of that. Ooh, uncharted territory. Okay, so now let's talk about identities. We're going to start with the reciprocal identities. So first we're going to start with cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. And cotangent theta is the reciprocal of tangent. We also know that tangent has to be sine over cosine. Why is that? Well, if we come back here, tangent was y over x. Well, we know y is sine and cosine is x, so that's where we get that tangent is sine over cosine. So cotangent could also be known as cosine over sine. We also talked about the complementary identity, which means sine of theta equals cosine of 90 minus theta. And then we talked about the Pythagorean identities. So the big one, sine squared plus cosine squared equals 1. We also talked about the other forms. So we can manipulate that identity. So we could do like subtract sine squared from both sides and we get cosine squared equals 1 minus sine squared and all that. And then we talked about others. I'm just going to keep it focused on that one. Let's do an example. Let's say I want sine theta tan theta plus secant theta. Our job is to simplify that. So the first thing I like to do is just change everything in terms of sine and cosine. And I like to keep them as fractions. And secant I know is 1 over cosine. So let's see, that becomes sine squared theta over cosine plus 1 over cosine. I'm actually going to make this a subtraction, and you'll see why. So now these have a common denominator, so I can actually go sine squared theta minus 1 over cosine theta. Sine squared theta minus 1. I should have a big red flag if I see a squared identity in 1. And that's something a lot of you missed on the test. Sine squared and cosine have to be squared. Like, they have to be squared, otherwise it doesn't work. And so I'm just going to manipulate that equation until I get sine squared minus 1. So if I'm just going to do it off to the side here. Sine squared theta plus cosine squared theta equals 1. Well, I want to subtract 1. And then I'm going to subtract cosine squared. So I get sine squared theta minus 1 equals a negative cosine squared theta. So on top there, I get negative cosine squared theta divided by cosine theta. Well, hey, that's like 2 cosines up top and 1 on bottom, so 1 is just going to cancel out. And I get negative cosine theta. And with a lot of these, there's not one right way to do it. There are usually many ways to do it, but they're always going to get you to the same answer. So I don't think you have anything super involved. Like maybe another example, you might have like 1 minus cosine squared theta over sine squared theta. 1 minus cosine squared, well, if I'm looking at this identity down here and I subtracted cosine squared from both sides, I would have sine squared theta. Well, hey, sine squared theta divided by, well, what's anything divided by itself? 1. And that should be enough to get you through Unit 7.